we're going to deal with a little bit of symbolic representation. So this is extremely useful when we want to kind of represent unknowns with equations. Sometimes it could just be one equation, sometimes you use multiple equations. When you get multiple equations with multiple variables, that's when you're thinking that you might have a system of equations. So you kind of need to be familiar with both in order to be successful when trying to solve some hefty story problems. So the first part of your assignment, you'll notice that there's kind of a little bit of review with each of those, with your equations, with your system of equations, and hopefully that kind of builds you to get ready when you get some tough problems that we'll look at right at the end of this thing. So let's do an example of a little bit, less involved one. It says the customer service team had planned to double the number of calls answered the second day, but they exceeded that by 3 dozen. 75 dozen customer service calls in 2 days set a new record. How many dozen of calls were made the first day? Oh boy. I mean, some of you might be able to look at that and you can think through it just quick and mentally, and you just got it right now. I mean, I get it. That is just too much information. I'm super confused. So my first thing I always try to do is I always try to answer the question, what do I not know? What is it asking for? Well, it says how many dozen of calls were made the first day. So usually I give a variable for that. So I'm going to say first day, dozen of calls. And I'm going to give it, I'm just going to call it X. Okay, that's kind of our most common variable. All right, so that's what I don't know. X represents the number of dozens of calls in the first day. All right, and then it says that they had an X number of dozen of calls the first day. So let's see, I got the first day we made some calls, right? So first day calls. And if we add that to the second day calls, it should equal our total calls. So sometimes coming up with a represent, how it can be added up, how I can set up an equation, that might help. And we already talked about that. We're going to use X. I mean, you could use any letter. X for the number of dozen of calls that first day. So I can fill it in this first spot. And we also know something that's pretty easy, that we finished with 75 dozen calls in those 2 days, and it set a new record. So we know that it totals 75 dozen already. Well, what can we do for the second day? It says they planned on doubling the number of calls answered. So they planned on this, plus they exceeded that by 3 dozen. So they planned on doubling it, so they planned on that. So that's 2x, right? Twice the number of that first day, plus they did another 3 dozen. So what do I put there? 3 or 36? Well, all these numbers represent dozens of calls, right? X is dozens of calls. This is 2 times the number of dozens of calls, so that's a dozens. This is in dozens. So we want to use 3, because all of our numbers are representing dozens of calls. So I could use that to represent my situation here. And now it's just our simple algebra, so I combine like terms. So x plus 2x gives me 3 total x's, not 2x squared, right? It's not multiplication with our x's. And then we still have our plus 3 equals 75. And now whatever you do to one side, do to the other. So we subtract 3 from both sides. And we got 3x equals 72. Divide by 3. So how many dozens of calls? We got 24. 24 dozens of calls. Should I just write 24? No, always put a label. I'll write that over here. So 24 dozen calls. Always have a label for story problems. Okay? Do not forget that. There we go. So just some quick review on a couple things. Hopefully we're familiar with this. It says rewrite each expression without parentheses. Well, if you take a look, that's our distributive property, right? Anytime you have something written in front of parentheses or after parentheses, that means you just got to distribute what's in front of it as long as it's a monomial, which means just things being multiplied. So since there's no plus or minuses in between there, I can distribute that whole thing. So I just take the 10x and multiply by each term. So 10x times x squared would give me, well, 10 doesn't get multiplied with anything, and x times x squared is x cubed, right? We add our exponents. And then 10 times 10 would give us minus 100. All right, and moving over here, and I can't combine like those terms, so that's done. Over here, you could write this either way, right? Multiplication is commutative, so I could flip-flop this if I wanted to. I could write this negative 6m out front, just like this. It doesn't matter. I'm still just distributing to each term, right? Okay, same thing here. So negative 6m times 8m. Well, negative 6 times 8 gives us negative 48, and m times m gives us m squared. And then we got a negative times a positive 5, right? Negative 6m times, so negative times a positive is a negative. So, right, negative times a positive is a negative. And 6 times 5 is 30. And we still have our m left over, right? Because m, nothing else to multiply there. Can't combine those two terms because they're not alike. And we're done. Okay, so hopefully that's just a little bit of review. Same thing with here. Solving equations, remember? We just got some simple rules, right? Get your variable to one side first. Get it by itself. That's kind of all there is to it. So either way, I can either move this 3p over to this side, or I can move the negative 9p over to that side. My goal is to try to keep my variable positive. So in this case, I'm going to use this negative 9p. Because to get rid of it and then move it to the other side, I have to do the inverse of what's being done. So I have to add it over. So to get rid of that negative 9p, I have to add 9p, and whatever I do to one side of the equal sign, I got to do to the other side of the equal sign, so I got to add 9p. Well, I should do it to its like terms, so I put it under the 3p. And then we just work straight out. So bring my negative 14, didn't touch it, 3p plus 9p is 12p equals, well, those canceled, that's why I did that, right? That's why I added the 9p, and then I got my negative 21. And now we want to get our p by itself. Well, I can't divide the 12 yet because it's connected here. We kind of work backwards with our order of operations. So I got to move this negative 14. So to get rid of a negative, we do the inverse, which is a positive 14 or add 14. Whatever I do to one side, do to the other, right? Just all of our algebra rules. So that's gone. Bring our positive 12p down. Don't need that plus sign anymore. And negative 21 plus 14 gives us negative 7. And then lastly, to get the p by itself, we're multiplying here, so the inverse of multiplying is dividing. So divide by 12, get the p by itself. So p equals, and always just leave it like that. Never write sloppy decimals. So we'll just bring the negative sign out front for it to be aesthetically pleasing. Negative 7/12. Just remember that. Negative 7 over 12, 7 over negative 12, and negative 7/12 are all the same thing. Okay? If I try to put negatives on both of them, now that becomes a positive 7/12, so that's different. But all these are the same thing. We just like to put it out front because it looks a little nicer. Okay, last thing. Oh, sorry, two more things. When you get something like this, when we're substituting in for given values, at this point in time, we want to save our time with things like this because we're going to be more so solving like bigger problems where we don't want to like spend the work trying to do this by hand. Some of you might actually be able to do this mentally. For example, right, I'm plugging in the negative 12 for x, you know, the 9 for y, and then the 24 for z. So I'm just going to write it out here quick. So 5, 6, remember I like to put it in parentheses, plus 2/3 times 9 minus 7/12 times 24. I bet some of you could do this mentally and think, well, if I broke 6 or 12 into 6 parts, they're all 2. And if I want 5 of those 2s, 5 times 2 is 10. So 5/6 of 12 is 10. And a positive times a negative is a negative, right? Some of you could probably do that mentally. If you have trouble doing mental math, that's okay. We're going to help you with the calculator here in a second. Over here, well, if I broke 9 into thirds, they'd each be worth 3. And if I want 2 of them, 2 times 3 is 6. And lastly, if I broke 24 into 12ths, they'd each be worth 2. It's 24 divided by 2. And if I want 7 2s, I would have 14, right? 7 times 2. That's kind of how I do that mentally. And then I work through negative 10 plus 6 is negative 4 minus 14. I like to add the opposite, so negative 18. Okay, if your mental math isn't that great, that's okay. Let's take a look how this works with our calculator here. Okay, so I busted out my trusty TI-84. It might be good to take this out right now and practice with me. Okay, anytime I write a fraction in this calculator, I like to put it in parentheses so I don't make any mistakes. So for example, when I do 5, 6, I'm going to start with my left parenthesis and I'm going to go 5. Well, how do I get that fraction bar? Well, what operation is fractions? Division. So divide. So 5 divided by 6 and that parentheses. So there's my fraction. And we're multiplying by negative 12, right? So I can either hit times or I can simply just put it in parentheses. because that's the same thing as multiply. Just like that. So that's 5, 6 times 12. Uh-oh, what did I forget? I forgot a negative sign, right? So let's go back. Just don't forget, a negative sign is different from the minus sign. So I need to click the negative sign, which is down at the bottom next to the period. Don't confuse those, otherwise it'll screw things up. So negative 12. And it should follow your order of operations, so you can just type it in just like that. So plus, got to put my 2/3 in parentheses, so 2 divided by 3 in parentheses. And I'll just throw that 9 in parentheses to multiply, and then minus, and same thing. Put that 7/12 in parentheses, and times. Always look back and forth to make sure your buttons work when you click them. 24, so I'll just put that in parentheses as well. And if I hit equals, negative 18, same thing, very good, okay? So whatever's quickest for you, go with it, right? And if you like to do things mentally, it might help to just double check with your calculator. All right. Let's take a look at our last thing. So let's go a little bit more in depth now with a story problem here. All right, so let's read through this. It says, according to Mrs. Randolph's will, each of her great-grandchildren living in Georgia received $700 more than each of her great-grandchildren living in Florida. In all, $206,100 was divided between 36 great-grandchildren. The Georgian great-grandchildren, decide that the will wasn't really fair, so they each contribute $175 to be divided among the Floridian, great-grandchildren. If all great-grandchildren now have equal share, how many great-grandchildren live in Georgia? Whoa, Mr. Renzel. My head just exploded reading that sucker. Holy buckets. Okay, well, here's my best advice. Break it down, give variables to unknowns, start writing some equations, right? Try to break things down, right? So let's go to the top. Mrs. Randolph's will, each of her great-grandchildren living in... Okay, so she's got great-grandchildren in Georgia and Florida, but we don't know how many there are. So first thing, let's give a variable for the number of great-grandchildren in Georgia. How about G? That seems perfect, right? Number of Georgia great-grandchildren. So what do you think we could use for the number of great-grandchildren in Florida? F. Love it. There we go. This might even mark that. I'm going to put G for the number of great-grandchildren in Georgia and F for Florida. And I could actually write an equation with that right away. Because what's the total amount of great-grandchildren? 36. So G plus F equals 36. There we go. I already got two variables and an equation written down. That's a great start. Okay, well, what else do we know? We know that the Georgia great-grandchildren got $700 more than the Florida great-grandchildren. Well, let's bring in that dollar amount. So I could have a variable for the amount of money each Georgia great-grandchildren got. So let's use X for that. The dollar amount that each Georgian got. And I could use Y for the amount that each Florida great-grandchildren got, each Floridian. Okay, and so I could write another equation right away because I know that the Georgia great-grandchildren, the amount, so X is the amount that they got, was 700 more than the Florida one, right? So I could say Y plus 700. Right? So if the Florida one got $100, the Georgia one got $800, okay? Obviously that's not even close because, man, she gave away a lot of money here. So there's another equation I just wrote. And I could use those variables to write another equation. Just think about this. What else do we know about some totals of money? We know that she gave away, there it is, $206,100. Okay? So basically it's saying the total of the Georgia plus the total amount of the Florida equals that 206,100,000. Well, how do I figure out the total amount of money that the Georgians ones got? Well, how many there were times how much money they each got. G times X. Same thing for the Florida. How many there were times how many they each got. And that equaled that total of 206,100. Man, so I got 3 equations so far. It doesn't look like I can solve for any variables yet. So, and I don't really have a system I can set up yet. Remember, a system, you need 2 equations with 2 variables. None of them really match up that well. So let's keep going. So it looks like the Georgia ones each gave 175 to the Florida ones to make it even. So there's another equation you could write. I could say that the Georgia ones the amount, right? The amount. So X, they each gave 175 to the Florida ones, right? But it doesn't equal Y, right? It doesn't equal what the Florida ones have. What does it equal? Well, can we bring in a new variable into play? Sure. Remember, when we subtract 175 from the Georgia, the amount of the Georgia ones, it's going to be the equal amount that each one has now. So we could say D represents the amount every single grandchildren ended with, because that's the fair amount. So when we take away 175 from the Georgians, each Georgian, right, then the total that each grandchildren, for all of them, they get is D. Okay, we're getting close here. Well, what else do we know about D, the amount that they each have? So now if it's fair, if D represents, like it's an equal share, if we multiply that by 36, the total number of grandchildren, that should equal our total. Ooh, how does that help us? That can help us solve for D right away. Let's go ahead and do that. I can divide by 36 on both sides. And if I divide by 36, I end up with 5,725. So basically, each great-grandchildren has $5,725 now. Well, now I can start using that. I can plug this amount in for D up here, to solve for X. So I'm going to go ahead and do that. I'm going to take 5,725 equals X minus 170. So basically I'm just adding 175 onto that, which in that case, X would be 5,900. So that's the amount that each Georgia got, 5,900. Okay, and we know that each Floridian had 700 less than that, so we automatically know that that was 5,200. I don't even really have to plug that in. I could plug that in up in here and solve for Y, that's fine. Okay, well now how does that help me? I'm going to get rid of some of these equations now that I got some stuff written down. I got these two equations. Well, I know what X and Y are, right? So I could plug that in for X, and I could plug that in for Y. So now I got G, I'm going to put the 5,900 in front. 5,900 G plus 5,200 F equals 206,100. And I still have this other equation. I'm just going to bring it down low. I got G plus F equals 36. Well, if you notice, you have two equations with two variables, G and F. So hopefully that should set something off from your intermediate algebra days, your Algebra 1 days, that is a system of equations. Two equations with two variables. So a lot of ways you can solve a system. You can do it by elimination, you can do it by substitution. The easiest way in this case is by substitution. So for example, I could get G by itself by subtracting F over to the other side. And I'd get G equals 36 minus F. Well, how does that help me? If G equals that, I can take this and plug this in for G into my first equation. Alright, so we're plugging that back in. So I got 5,900 times 36 minus F plus 5,200F equals 206,100. And now we just got to go through our algebra and simplify. So a lot of stuff here. I got to distribute. So that gives me 212,400. And then I got 5,900F plus 5,200F. Some of you might be able to skip some steps here, but I'm going to write this all out because now I can combine my like terms here, which gives me what, negative 700F. So I got negative 700F there. Bring everything else down. Got our 212,400. And now we got to get our F by itself, so we subtract that 212,400 from both sides. Extend my page again, get some more room to work. So we got negative 700F equals negative 6,300. And lastly, divide by negative 700. Oops. Divide by negative 700. Really, the zeros cancel, and negative 63 divided by 7 gives us 9. So F is 9. So that's what? The amount of Florida great-grandchildren. And what did our original question ask for? And we're going to have to go way back up top here. It said, if in all, great-grandchildren now have an equal share. How many great-grandchildren live in Georgia? So if 9 live in Florida, well, 36 minus 9, which gives us 27. So our final answer is 27 great-grandchildren. And you can abbreviate that, grandchildren, right there. 27 great-grandchildren live in Florida. Wow. So it took a little bit of work. It was kind of overwhelming right away, but just give variables for things you don't know. Okay? Try to start solving things. And just remember, like, anytime you have two variables and two equations, that's a system. You can always solve a system by substitution or elimination. So just using a lot of things that we've learned in algebra in something that seemed pretty overwhelming right away.